you. And we're going to go through the majority of these questions. We will finish it up tomorrow, and you have a test come Monday. Oh, I think it's a Friday. Who's Chris? Who's Chris? All right. All right, so the first one, I don't think I need to go over too much. It says, is it the sequence arithmetic? If so, identify the common difference. Remember, in order for it to be an arithmetic sequence, you have to be adding the same number every single time. If you look, 14 to 21 is 7. 21 to 42 is not 7. Does that make sense? So it is not arithmetic sequence. So no would be your answer. For number 2, is it an arithmetic sequence? Are you adding some number to that each time? Yes, what number is it? 12.2, so your answer should have been B. 3, now we're going to start getting into this stuff. It says find the 110th term. Please, please, please understand this is what we've talked about. When I say A1 equals -7, and I say A2 equals 3, why can that be confusing? So how many numbers are describing this spot right here? 2. First term, that's a number, right? And it's describing how many numbers into this sequence it is, right? This is what number is filling that spot. So it's like first term, second term, third term, fourth term, right? And this is the number that's filling that spot. This is the number that's filling that spot. Do you get what I'm talking about? So that's you'll need that information for next time. For a problem in just a little bit, I'm kind of setting this up. So if I said I want to find the 110th term, that's a what that I'm trying to find. So I'm trying to find 110, and that is supposed to equal A1 plus the common difference. What's the common difference? 10. You should be able to look and see how you get from -10 to 3. If you don't see it there, remember it's got to be the same. So find the next one. How do you get from 3 to 13? 10, right? Common difference. And then times n, which is 110 minus 1. Order of operations out with this one. Why am I doing order of operations from top to bottom on this one? How come I'm not working backwards or having to do any of that bull crap? There's no variables there, guys. Since there's no variables, you can just do the math, meaning you can actually do 110 minus 1, which is, and then you can actually take that and times it by 10, because there's no variable there, right? And then you can actually combine these, because there's no variable there. And so you can tell me the 110th term should be 1083. Does that make sense? Number 4, for the recursive, write the explicit. There's actually a mistake on here. There's actually a mistake. What should they have put on this right here after this? There's missing something, and it's actually it's really important. It should be there. Yeah, it should have said it's 45 with a comma behind it when n equals 1. And then it should have said n minus 1 minus 5 for when n is greater than 1. This part is missing. That's kind of a big deal because that tells you if you put 1 in for n, which is right here, that would mean 1A1, aka what does that tell you? That's the first term. Why do I need that? Because when I need the explicit, my explicit formula says A1 plus the common difference, n minus 1. If someone ever asks me for the explicit definition, I need A1 and I need the common difference. So it's really important to know 45 is my A1. Do you follow what I'm talking about? The other thing is, this is the recursive. The recursive says you always use the term in front of it, and then you add the common difference. So what's my common difference right here? -5, which is what's going to go right here in that place. So I'm going to look for AN equals 45 plus, actually, -5 times n minus 1. And that should be your answer. Does that make sense so far? Questions on that one? Nick, any questions? I know you're striving for that A. All right, here's the one I was kind of setting you up for. It says 29 plus 32 plus 35 plus 38 plus 41 plus ... Also known as what in English? You don't know what ... is? It's an ellipses. Okay, yeah, it's an ellipses. Very good, Nick. And so that means that there's something missing. They're not telling you all the numbers in there. And then it says all the way up to 59. That means, is the 59 the sixth term? No. It means we don't know what number the 59th term is. But it's the last one, yes? Yes. So that means AN equals 59, but I don't know what term number that is. You follow me? Now, when they ask me to find the series of that, that means I'm supposed to add it up. And I know there's a formula for that. It says Sn equals n times A1 plus AN, all divided by 2. That's the formula. So I look at this and I go, do I know n? No, I don't. That's a question mark. Do I know A1? Yes. Do I know AN? Yes, I do. So what do I need to do? I need to use some math to try to find that n. What term number is the 59? And no, we're not going to sit there and try to count it up because that's cheating, especially if we're talking about something being the 100th term. You'll never finish my test if it's the 100th term and you just sit there and try to count up to it. Do you get what I mean by that? So the real way of doing this is using the explicit formula that says, hey, AN equals A1, which is what? 49. Plus? 59. No? Plus 3. Times? Yes? Yes. What term number are we trying to find? The last one, right? What number is in that last term number? 59 is in that, right? So what can I replace AN with? But what is still going to remain a variable? And do you remember last time how I said I need to learn how I know if I'm going forwards or backwards? What way am I going to be working this equation right here? Why am I going to be working it backwards eventually? Because I got n's in there and I got to do this. So there's a couple ways I can do it. And I'll show you, and the reason I recorded your class is because I can do this kind of stuff when I have more time. So what I can do, I'm going to show you, there's not one way to solve this. We taught you a trick when you have something in parentheses, and we can't do, remember how last time we had 110 minus 1, and we could actually do that math? I can't do this math because it's what? It's n minus 1. I can't say n minus 1. I don't know what it is because I don't know n. So what did we say there was a trick that you could do? You can distribute the 3. That's one way of solving this. I'm going to show you 2 ways of solving this. You'll get the same answer. Because I'm trying to get you to understand in math, there's not necessarily only one way. Okay? All these are just tips and tricks that you can do to solve equations, and you gotta learn when is it easier to do which way. Sometimes they're both kind of the same. Does everybody understand what I did there? Now what can I do? I like to combine like terms. I like to simplify one side before I start bringing crap over to the other side. So I can combine the 29 with a minus 3, and I get 26 plus 3n. Now I can't combine any more things on that side. So now I gotta start moving stuff to the other side. So I minus 26 from both sides. I get 33 equals 3n. Divide by 3, divide by 3, and I get n equals 11. Is that my final answer? No, that just helped me get what I needed to finish off my problem up with originals. Yes?
Yes.
Now, here's the other way I could solve this. I could minus the 29 first. And then I get 30 equals 3 and minus 1. That's okay. What's this 3 doing to this whole thing over here? So how could I undo it? And then I get 10 equals n minus 1. And then what could I do? Add 1 to both sides, and what did I still get? It doesn't matter which way you do those, you still get the same answer. That's the thing that kind of sucks about Algebra 2, honestly. You got to know all these kind of different things. It's not, what I'm trying to say is it's not one set way. Okay? All right, so that's that. So now we can restart this. I'm going to erase it just like that. It makes it easier for me. Sn equals, what was our 11 we found n to be? That's what we just did. What was our first term? Plus all divided by, and I'm not going to do this. I'm hoping you know how to do this in a calculator. Am I working forwards or backwards in this one? Why? There's no variables, meaning you can actually add 29 and 59 together because they're numbers and you get a number, right? Then you take that number that you added and you multiply it by 11 because that's what that means. And then I take that number and divide it by 2 and I get my final answer. So it should have been C, 484. Yep?
Yeah.
Questions on this stuff? Is the next question any different technically than the one we just did? No, it is not. It's the same exact question. The format of it is just different. I should recognize that this is going to be an arithmetic series, or sequence, right? What does the E? You okay? Someone talking about you. Ooh, I almost fell. If I fall, y'all laugh.
Yeah, but
Please. Because if you fall, I'm laughing.
I know you are.
Especially you. All right, what does the E mean? Add means everything together. It's called sigma. It means summation. It means add all of your answers together. And it's telling you to plug, technically you should plug in 1 all the way up to 85. So if you wanted to get the series of this, if you wanted to get the actual sequence, you plug in 1. 1 times 2 would be 2. 2 plus 6 would be 8. Yes? You following me? Then you could plug in 2. 2 times 2 would be 4. 4 plus 6 would be 10. Do you get what I mean? Then you can plug in 3. 3 times 2 would be 6. 6 plus 6 is 12. Right? What do you think the next one would be? Right. And so what do you get? What are you doing when you use the term in front of it? You guys are using the. We gotta see this stuff. No. What formula are you using when you use the term in front of it? Nope. Recursive. You are using recursive. This is why I said you gotta study this stuff because you should know it. We talked about it. This is recursive where you're just using the term in front of it. We're no longer doing this. But how many times do we have to do this? We would have to do it 85 times. Do you want to do that?
No.
It's a good thing there's a formula, right? I believe this one is Gauss's. The guy who came up with it, his name was Gauss, so they called it Gauss's. And the other one, I can't remember their names. I'll have to look it up. But they actually have their names. This formula has a name. I believe Gauss is the one who came up with the arithmetic. He did. He discovered it. You're right. So here we go. It's going to be Sn equals n times a1 plus an all divided by 2. How many terms am I going to have in this sequence? If I plug in 1, and I plug in 2, I plug in 3, I plug in all the way to 85, how many terms are there going to be? There's going to be 85 of them. Yes? What happens for A1? What is A1 in this case? Good. Plus, how do I find the last term? What am I going to do? I'm going to plug in 85 for X. Don't hurt yourself. 85 times 2. Well, if you can't remember that, don't forget that you can do this kind of stuff, right? That's a 0, carry the 1, 170. Then you add the 6 and you get 176. All divided by 2. Again, are we working forwards or backwards? And how should we know? We're working forwards because there's no what? So that means I can actually add these two together. They give me a number. I then multiply that number by 85 and finally finish it off by dividing by 2. And you get an answer of, so A is your answer. I better check y'all. Oh wow, you guys are right. Question? Questions? All right, so the next one I'm not too worried about, especially since it's kind of a nasty intersection. But I'm going to show you how I would do this one, especially since it's multiple guess. And we have something to talk about that I really didn't explain too well because I kind of let you do the easy ones first, and then I'll explain where they get a little trickier. So let's go ahead and do this one. If I was graphing this one, what do I recognize that it is? Going to be a line. How do I know that before anything else happens? Do you see how these people are talking? Come on. Daisy, how do you know that? Because x is to the power of 1. It has to do with the power. The power is going to tell me everything about the shape of this graph. In fact, we're going to study that chapter 2, 3, 4. We're going to really talk about those powers and what they mean about the shape of this graph. Okay? So it's because it's x to the power of 1, I know it's going to be linear every single time. If it's x to the second power, what do I know? What kind of shape is it going to be? A parabola every single time. Okay? If it has absolute value, what kind of shape do I know it's going to be? A V shape. So we're going to use that to help us get this answer. So let's just graph this guy. I know it's linear, and I know what form is it in. Whoops. Nope. Slope-intercept form. Here's my intercept. 1, 2, 3. My slope is -1. How do I write -1 as a fraction? -1 over 1 or 1 over -1. Both of those are the same number, just written differently. In fact, 1 makes me go down, and to the right one makes me go up, but to the left one, but you see, they're on the same kind of angle. You follow what I just did and how I graphed that fairly quickly. Now for this next one, here's what I did not talk to you too much about. Do you remember how we could have horizontal stretches and compressions? And remember how they're on the inside? Okay. Because of this 3 right here, that 3x, it's not just an x, I have to try something before I can know how far it was shifted left and right, and how far it was horizontal, compressed, or stretched. Please listen to this, because it's going to come up for next chapter. Do you remember how, back in middle school, and this is what happens constantly in math, if you can go forwards, you can always go backwards. Here's what I mean by that. We just did this. What can you do with that 2? You can distribute it, correct? And what does that become? Now, what happens if I have 2x plus 6? Sometimes I don't want the 2x plus 6. Sometimes I want to change it back to the other form. And so I can actually go back to this. And the way we do that is you look at these two numbers right here and you say, do they have something in common? What do they have in common? 2 goes into them. 2 goes into 2x. 2 goes into 6. So you pull that 2 out in front, and then you say 2 times what would get me back to 2x? X. 2 times what would get me back to 6? 3. And you put those missing pieces there. So here's what we're going to do. Yep, let's do for this next one. This is, I call it undistributing, but it's just distributing backwards. That make sense? So what do 3x and 9 have in common? So I would write it, I pull a 3 out. And then I go, okay, 3 times what gets me back to 3x? Good. 3 times what gets me back to 9? So actually now, this is how I'm going to use this. This tells me when it's bigger than 3, remember it's on the inside, it's going to be a compression because it's on the inside, it's the opposite. So it's a horizontal compression. So imagine you have a V and someone compressed it together. What's that V going to do? It's going to get skinnier. It's going to go up faster. It's going to be very skinny. So I kind of have that in mind when I graph this. You with me? And then what does this tell me now? Move left 3. So 1, 2, 3. So this should be my ordered pair. By the way, how can I check that? What does that tell me that if this is an ordered pair, what does that tell me should happen? If I plug a -3 in for x, my output should be what? I plug a -3 in, my output should be 0, correct? Well, what's -3 plus 3? What's 0 times 3? What's the absolute value of 0? Did I get that ordered pair out when I plugged in -3? That's just me checking, saying, hey, I know I did that right. So what would be another point that I could plug into here that would make this really easy, and I could make sure that this intersects with this line here?
No, negative, no, 0.
0. If I plug in 0, I'm over here, correct? Don't I know that this V will have to run into that? Do you get what I mean by that? Unless it runs in way over here. So I'm going to do 0. So if I plug 0 in, 0 plus 3 is 3. 3 times 3 is 9. Absolute value is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This is what this V is going to look like. Correct? And if it does that, it's going to look like this on the other side. Do you follow me? Okay. How many times is this line and the V going to intersect? How does that help me out? They're going to hit twice. How does that help me out looking at your answer choices? What ones can you eliminate? Wow. You can eliminate C and D. Why? They only have one answer choice, and I know it's going to intersect twice. Yes or no? Okay? Look at where this intersection is. If I look at that, where is that about? A negative 1.5, because it's back, right? And isn't this intersection, if I kept going, 4, 5, 6, isn't this intersection close to a -6? So what would be my answer choice now? Do you guys understand how I did this? Now, if I was doing it without a multiple choice, I'd have to do it better, but I promised you, if it's not multiple choice, I'll make it to where it's clear answers. It won't be hitting at like 1.5. Because you'll never see that on the graph. Remember how we talked about that? But do you have an idea of how to find this now?